Hello guys, welcome to the Precalculus class. I am Tyrone L. Delfin, your subject teacher in Precalculus. I welcome you, grade 11 students of the Science, Technology, Engineering, and Mathematics strand. Our first lesson is on the Conics section. So, um, Conics section is actually a part of a greater study, which is analytic geometry. Analytic geometry is the fusion of two branches of mathematics, algebra, and geometry. With the use of the Cartesian plane, figures like points, lines, and shapes like circles, parabola, etc. can be given equations that accurately represent their location and dimensions. Before, uh, algebra and geometry were independently studied. Algebra is the study of representing um, representing unknown things using variables and then solving for it. Geometry is the study of shapes. With the use of analytic geometry, the two independent studies became one single grander study. The conic section is actually a part of the analytic geometry, and the conic sections are plane figures derived from the intersection of a plane and a double cone figure called naps. Do you see the naps? Um, there, there's the naps. Okay. And when a plane intersects the naps, different figures are formed. So, what are the figures created by the intersection of the naps in the plane? First, a circle. A circle is created when the plane slices one of the naps in such a way that the altitude of the cone is perpendicular to the plane. So, let's look at the circle. Do you see the circle? Yes, the circle. The circle is right over here. Uh, but do you see the altitude? The altitude is actually an imaginary line that passes through the vertex. The vertex is the intersection of those two cones. It is an imaginary line that is directly passing through the cone. Just imagine a straight line pinching through the two cones, and this is actually um, perpendicular to the bases of the two cones there. So the circle there is actually perpendicular to the imaginary line called the altitude. Okay, so that's the circle. Second, an ellipse. An ellipse is formed when the plane slices one of the naps at a tilted angle. So it's not perpendicular. So it's not perpendicular to the altitude. At a certain angle, you can create an ellipse. So do you see the ellipse? Yes, the ellipse is right. The ellipse is right over here. It's under the circle we have found, and as you can see, it is tilted at a certain angle against the against one of the cones. So we have an ellipse, and guys, I would just like to tell you that an ellipse is different from an oblong they may look the same, but they are actually different. Ellipse is part of the conic section. An oblong is any circular, semicircular object. Okay, so that's the ellipse. Third, the parabola. The parabola arises when the plane cuts through one of the naps in such a way that the cut is parallel to the slope of the edge, producing an infinite ever-widening figure. I forgot to tell you guys that the naps is actually a pair of two cones that are extending infinitely in opposite directions. So just imagine the cone extending infinitely over there, as well as here, and then the parabola is made when the plane cuts through the conic in such a way that the plane is parallel to the edge. So a parabola is an infinite curve. It's an infinite curve. Just as the naps is also infinite. So let's proceed. Fourth, the hyperbola. The hyperbola is made when the plane passes through both of the naps and the plane is parallel to the altitude of the cones. So the hyperbola. There's the hyperbola. Again, the altitude is an imaginary line passing through the vertex of the two cones. So it's right over there, and as you can see, the plane is parallel. It's parallel to the vertex, cutting the naps into two parabola-like structures, but they're not parabolas. No, they're not a hyperbola is different from a parabola, but it may look like the hyperbola are a pair of parabolas, but it's not like that. Okay, so that's the hyperbola. These four are all part of the conic section and will be the subjects of our study in 4 weeks time. So in 4 weeks we are gonna study them one by one, one conic per week. Are there other figures arising from the intersection of a plane and the naps? Yes, there are 3 more: the point, the line, and a pair of intersecting lines. These 3 figures are called the Degenerate Conics. So they are actually not proper conics. So they were called degenerate. Why not proper conic? Because they are not curves. Conics, the proper conic sections are actually a collection of curves. The circle is a curve. The parabola is a curve. An ellipse is a curve. Hyperbola is a curve. The point, the line, and the pair of two intersecting lines are not curves. So they are not really a part of the conic section. They are the degenerate conics. How are the degenerate conics produced? You are challenged to find out how. So how? Maybe you can post a video of you doing the challenge, or you can just create any written diagram of you doing that. you can send me those proof of your act. We've only seen geometry here. Where is algebra there? Oh. Again, equations will be used to represent these figures in the Cartesian plane. In this case, since we only have two dimensions, we use two variables, x and y, to represent equations. During your high school years, you've been acquainted with the point represented using a coordinate pair, x and y. You've already made equations of lines of the form ax plus by is equal to c, where a, b, and c are constants. This time, you will be seeing equations in two variables in their second degrees. So, when we have a second degree equation, we expect a curve. These equations have a general form ax squared plus by squared plus cx plus dy is equal to e, where a, b, c, d, and e are all constants. These equations are the equation of the conic section. We will tackle the conics one by one, starting with the circle. Thank you. Next presentation is on the first part of the conic section, the circle. I'll see you on the next video. Bye.